Assalamu alaikum everyone. I hope all of you are doing well and Ramadan is easy for you. May Allah accept your fasting and your prayers. Ameen. As I promised, we'll keep talking about the final exam so you don't have any anxiety about the exam. So today I would like to share with you one type of questions that you are going to see on the final exam, and this is the true-false questions. True-false questions appear easy. You think you're gonna just read the statement, but sometimes it is difficult because you really need to read the statements carefully. So I give you an example here. Let's read the statement together, and of course the direction for the question is mark the statements true or false. A equals true, B equals false. So you're going to bubble in A if the statement is true, bubble in B if the statement is false. The statement is saying randomly selecting subjects for participation in a study must be done using computer-generated random numbers. When you see a word like this that is in all caps, you need to pay attention because this word is in all caps for a reason. It is emphasizing the word must. It means that you cannot do this without this. So randomly selecting subjects for participation in a study must be done using computer-generated random numbers. Means that if you don't have computer-generated random numbers, you cannot do random selection. Is this a true statement or a false statement? If it is true, you bubble in A. If it is false, you bubble in B. So this is another type of questions that could appear on your actually will appear on your final exam, and I hope you do well. If you read the statement carefully, you will do well in these types of questions. Today we're going to talk, remember we have been talking about evidence-based practice, and we talked about the fact that if we want to practice according to the evidence, then we should be able to find the evidence. And we talked about the different databases and how to ask a question and how to find the answer for the question in different databases. Last time we talked about the sample and how to understand how the researchers pick their samples and what is the best way to pick a sample for a study, and how to do that, and the different ways researchers select subjects for their study. Today we're going to talk about measurements, the things that we measure in research. Researchers measure different things, and they measure different things that are related to people, that are related to the environment, that are related to equipment, that are related to a pathology, many things to measure. So we are measuring the things that we are measuring are called variables. So the variables can be really anything. I'll give you some examples of variables that are related to individuals or people. For example, the age. For my sample, I can have I can measure age in a group of people, being a man or a woman, so that's the gender, race or ethnicity, which is really not very important in a country like Egypt, because most people are from the same race and ethnicity. But in a country like the United States, this is a very important variable, because in medicine in general and in physical therapy, actually even in social studies and research, because as you know, some different diseases can affect different race and different ethnicity. Type of pathology, of course, is an important variable. Level of impairment in body function. Can the person do activities of daily living with minimal assistance, with moderate assistance, and so on? Level of impairment in body structure. If I have ligamentous tear, is it grade 1, grade 2, or grade 3, and so on? Activity limitation and participation restriction. These are important variables as well. How much the pathology is affecting the level of activity of a person or his ability to participate in community activity. And participation is another word that is important, especially in the ICF model, the International Classification Model, because if the person is restricted from participating in activities, for example, going to Jum'ah prayer or going to church on Sunday, these are important things for some people. So when they are not able to do that, then there is a participation restriction that can really affect a lot of things. There are variables related to functional performance, for example, and in physical therapy we have so many of those. I can measure strength, I can measure flexibility, for example, length of hamstring or range of motion, endurance level, balance, and so on. So many variables we measure. Now, all of these variables are not the same. As you can see, there is a variety of variables, and each one fits under a different category, and that's what we're going to talk about: how to classify variables and how are they different from each other. Use of variables in research is different if we are talking about non-experimental research versus experimental research. Remember, in non-experimental research, I am recording phenomenon and things as they happen naturally in life. So in non-experimental design, I'm trying to acquire information about specific variables of interest without influencing their behavior. So if I am doing a study on you as a class, I am getting, for example, I can get your age, I can get data about how many years after graduation, what is the area of practice, why did you get into the DPT program, and so on. So all of these things happened naturally. I did not do anything to the class to change your behavior or your answer or whatever I'm measuring in any way. In experimental research, and of course in quasi-experimental designs, it is different, because I'm doing an experiment, so I am actually intentionally influencing the variables. So intentional manipulation of the variables of interest. So if I'm doing an exercise program, I'm hoping that the strength, for example, is going to change. Range of motion is going to change. Balance is going to change. Something is going to change. So I am intentionally imposing something to change variables. So this is the difference between non-experimental designs and experimental designs. Another important thing about variables that we need to differentiate between what is called independent variables and dependent variables. This is very important because when you collect data about variables and when you see that researchers collected data about variables, it's very important to know which one is independent and which ones are dependent, because that will determine how the researcher is going to analyze the data collected. So independent variables are the variables that are purposefully manipulated by investigators to produce a change in an outcome. So this is something that I am imposing on the subjects to change the outcome. So in the experimental and quasi-experimental designs, the independent variables are the interventions. So this is what I am doing to change the outcome. This could be use of ultrasound, use of shortwave, use of exercise, use of a specific mobilization technique. So all of these things are interventions. These interventions are independent variables. For example, there is a study here by SINS, and the study looked into the effect of an exercise program on strength and function in frail elders. Frail elders are the very old people who are very, very weak. So in here, the independent variable is the exercise program. In this model, the exercise program could be just one exercise program, and it could be an exercise program that has different levels. For example, I can have 3 groups. One group would have one exercise program that's very intense. The second group could be a moderate exercise. The third group could be mild exercises. So the exercise program could be just one thing or could have different levels. When the independent variables have levels, and these levels can interact with each other, this is called a factorial design. So independent variables can interact with each other, and in this case the data should be analyzed in a different way. We are going to talk about this again when we talk about statistics, but for now I would like you to know that independent variables, so if I can have 2 different things, they can be interacting with each other, and in this condition, statistically, the data should be manipulated differently. Now for the dependent variables, dependent obviously based on the independent variables. So it is the outcome of interest in the study. So that's what I'm going to measure, or I'm hoping that's going to change, so I can measure that change at the end of the study. In this study that we just talked about, they measured strength. So that's an outcome measure and a dependent variable. Function, self-report disability. So all these 3 things, all these 3 variables are dependent variables, and they are measured before and after the strength training program. The strength training program, remember, is the independent variable. That's the intervention. Studies about prognostic factors are a little different. What are studies about prognostic factors? When I'm trying to establish a relationship between 2 or 3 or 4 things. For example, I'm trying to establish a relationship between having wrinkles and the color of skin. Something like this. So I want to know if a specific color of skin is going to cause more wrinkles if the person is exposed to ultraviolet. So I'm trying to establish this relationship. There are so many examples, and I'll give you another example right now. The warning that I would like you to pay attention to is that these types of studies cannot establish a cause and effect between independent and dependent variables. So I cannot say that having light skin will cause wrinkles. more than having dark skin. I cannot say that this is a cause and effect. I can say that these two things are associated with each other, but they are not a cause and effect. They don't have a cause and effect relationship. Let me give you an example from this study. This study tried to establish, they have patients who had elective coronary artery bypass. So they chose, it was not an emergency surgery, they scheduled surgery for coronary artery bypass. In this study, they tried to establish a relationship between age, smoking history, and the post-operative complication after surgery. Is there a relationship between the age of the patient, the smoking history, and the post-operative complication? So if the patient, for example, is an older person, if the patient smoked before, is this person going to have more post-operative complications compared to a person who is younger and never smoked? Okay, so this is called a prognostic study. It means that I am trying to see the future. I'm trying to predict the future of this person based on age and smoking. Again, I want to emphasize that this is not a cause and effect. I cannot say that the older the person, if the person's age or the smoking, history of smoking, are causing the complications. But I can say that the complications are associated with age and smoking. So we talked about independent variables. We talked about dependent variables. And there is a third kind of variables that happen. So independent variables I decide, or the investigators decide. The dependent variables also under the control of the investigator or the researcher. But there is another type of variables that happen without control, and these are called extraneous variables. Extraneous variables are variables that can happen because of anything, because of the people or the environment or the equipment or anything that is not under my control. So extraneous variables are factors that can potentially influence or confound. It means complicate the dependent variable. So it can affect the dependent variable. Of course, other than the independent variable, because my intention is for the independent variable to affect the dependent variable. But in this case, if we're talking about extraneous variables, then it is something that's not under my control. As I said, extraneous variables or factors can be related to the subjects, the people. So if I'm doing an exercise program and then I had a couple of people who had really severe cold episode during the program, then probably they're not going to be participating as much, and that might influence the dependent variable, whatever it might be, if it is strength or skill or anything. Equipment, if I calibrated my equipment in the beginning and then I didn't calibrate again and the equipment is not consistent, then I can have an error in the measurement, and that would be an extraneous variable. Environment, example of environment, if the room is very cold or very warm. If I'm doing a study, for example, on nerve conduction velocity, we all know that temperature affects nerve conduction. So if I measure the half of the people on a hot day and half of the people on a cold day, or if one day the air condition was on and the other day the air condition didn't work, then that might affect my dependent variable or outcome measures. In this case, temperature is an extraneous variable that is going to affect my study. When you read a study, you need to evaluate for yourself if that happened, if any of this happened, and if the researcher was aware of these variables and controlled them. For example, for nerve conduction studies, researchers usually fix the temperature, so they tell you that they made sure that they measured the temperature of the room or the skin before they do the study every time to make sure that it is constant, it's not fluctuating up and down. So you need to determine for yourself when you're reading these studies the success of the investigators to control or adjust these variables, and if some were ignored or overlooked. Obviously, if they are ignored or overlooked, then that weakens the study, the results of the study. If it is well controlled, the study, then you can trust that study and feel that it can be replicated with minimal error. This emphasizes the importance of having a control group. If I have a control group, I have an experimental group and a control group, then whatever is going to happen is going to affect both groups, hopefully equally. So if I see results, then the results are not related to extraneous variables. The results are related to the independent variable that I am using. Because the control group, if the control group didn't have any change and the experimental group changed, then that change is due to the intervention or the independent variable. It's not due to chance or environment or any extraneous variable. Now, when we measure variables come in different quantities and qualities. So it is very important to understand the different types of variables related to what they're measuring. In physical therapy, we use a lot of continuous variables. Continuous variables, from the word continuous, they go for on and on and on and on forever. So they can actually be of any value along a continuum. That continuum goes on and on theoretically forever. They can never be measured exactly because really we are limited by the precision of the measuring device. For example, if I am weighing a person, I'm asking a person to get on the scale and I'm weighing a person. If I am weighing gold, I cannot use that scale because I need a more precise scale to measure something like gold. So the precision, الدقة of the measuring device is different here. Half a kilo is not a big deal, plus or minus in a scale if I'm weighing a person, but 1 gram could make a huge difference in a piece of gold. So our accuracy of measuring something depends on what am I measuring with. Am I measuring with a device that is very precise, or I'm measuring with a device that has a lot of error? By the way, this is a typo. It should be device, not device. So for example, height is a variable. Range of motion is another continuous variable. Maximum voluntary isometric contraction, the distance a person walks in 6 minutes. So all of these are continuous variables. They can carry any value, and it can have a decimal point, 2 decimal points, 5 decimal points, and so on. So I can be as precise or as gross as my measuring device would allow me. Another group of variables are called discrete variables. These discrete variables, I cannot have decimal points. I cannot say it is 5.5 or 5.4. They are described only in whole units. For example, a heart rate. I can't say that somebody's heart rate is 72.5 because a heart rate is a heartbeat. You can't have a fraction. Number of pregnancy. So a person got pregnant 3 times, 4 times, and they can't be 2.5 times. Number of hospitalization, number of surgery, weight-bearing status. All of these variables are come in whole numbers. They don't come with fractions. Sometimes these discrete variables come in a way that can only be answered in 2 possibilities, and these are called dichotomous variables. Dichotomous variables, they are discrete variables because they have whole numbers, they can't have fractions, but the answer to these variables can have 2 values only. For example, if I'm doing gender, it's either male or female. There is nothing in between. If I'm collecting data about handedness, the person could be right-handed or left-handed. He cannot be something in between. Test results could be negative or positive. Pregnancy, yes or no. We can't have somebody who is 50% pregnant. It's either yes or no. A smoker or a non-smoker. Somebody had cancer or never had cancer. So it is a yes or no. It is a positive or negative. It is always either or, nothing in between, and no third option. So these variables are called dichotomous variables. Again, all of these descriptions are important when we come to statistical analysis. And remember, when I asked you to read the articles, I asked you if the researchers did the correct statistics. And some of you commented and some of you didn't say anything, which was fine because we didn't get to that yet. But after we discuss statistics, you should be able, when you read an article, you should be able to judge and to evaluate if the researchers have done a good job in statistics or not. Another word about precision, again, دقة in measurements. That's the exactness of the measure. It depends on the sensitivity of the measurement tool. Again, a good example is the scale that you measure vegetables or fruits versus the scale that measures body weight versus a scale that measures gold. So sensitivity of these 3 scales is very different. The number of decimal places depends on the precision. For example, if I'm measuring 470s, this for example is 77.05849 Newton meter, and you see 1, 2, 3, 4, 5 decimal places. This happens to be shoulder internal rotation. Height of a person, 1 meter, 0.84058 meter. This person's weight is 80 kilograms, 0.93750 kilogram. So the question, is this useful? Is it important that I know that the person weighs 81 or 80.93750 kilogram. If I say that this person weighs about 81 kilogram, would this make a huge difference in the data? Probably not. Probably not. So again, it depends on the variable and depends on how am I going to use the variable. Maybe this is something if I'm sending someone in a spaceship to a planet, maybe I need to be very precise because of the calculation of gravity and some other things that will affect the person. But really on Earth, a person who is 80.9 kilogram is not very different from a person who is 81 kilogram. And if he had a glass of water or Pepsi, he's probably going to be, his weight is going to be different that much. Levels of measurements or scales is another important concept when we talk about variables. There is a hierarchy in the level of measurements or the different scales. Hierarchy means that somebody is higher than somebody else, or somebody is more precise than somebody else. Okay, and hierarchy could be when we say a company, the CEO of a company is on top of the company versus a small employee. So there is a hierarchy in the system of the company and in the employees of the company. In a school, there is hierarchy. You have the dean, you have the associate deans, and then you have the faculty, and so on. So when we say that there are levels of measurement or scales and there is hierarchy in the measurement, then this hierarchy is based on precision again, accuracy of the value. So in terms of level of measurements or scales, we have 4 levels that cover all variables. We have a nominal scale, ordinal scale, interval scale, and ratio scale. And because we have hierarchy, then they go in terms of precision. This is number 1, this is number 2, this is number 3, and this is number 4. So ratio scale is much more precise than interval scale, than ordinal scale, and definitely than nominal scale. Let me give you examples. For example, a nominal scale, nominal from name, so the nominal level of measurement, obviously it is talking about naming or categorizing. We can name people or we can name objects. So objects or people are assigned to categories, and that's why sometimes we call this categorical data. It is used as labels of an identification, but not order. And I'll tell you, and this is bold and underlined because this is important. Examples: sex or gender, we have males and females. There is no order. We cannot say that one is higher than the other. They're both equal. So males and females, we can talk about this forever, but I'm going to keep it short. So they are, there is no hierarchy, there is no order. They are either males or females, they are equal. Blood type, again, type O, type A, type B. There is no hierarchy. I cannot say that type O is higher than type B or higher than type A. If you have a patient with hemiplegia, it's either right side or left side. Test result again, positive or negative. Keep in mind that this is, yes, this is again dichotomous scale, but it's also nominal because I am naming or categorizing. If you have a survey question that have a yes or no answer, so for example, do you use an assistive device around the house? Yes or no. So these variables are discrete variables. In this case of yes, no is dichotomous, but at the same time it is under a nominal scale because you are naming or categorizing people or objects. They are mutually exclusive. Again, remember, mutually exclusive means they can't be overlap between the two. A man is a man, a woman is a woman. I know we can discuss this forever, but basically a man is a man and a woman is a woman. A blood type O is O and A is A. There is no overlap between them. A person either have right hemiplegia or left hemiplegia. There is no overlap. So the object or the person is assigned to one category only. He can't be assigned to another category. There is no overlap between categories. So that is important to know about the nominal scale. Another thing to know, if I want to analyze data, if I collected data about the blood type of your class, you are about 200 people. If I get the blood type of the class and decide, and at the end, after I analyze the data, I will say that 50 of you have blood type O, and maybe 30 have blood type A, and so on. So the only thing I can do with this data is to count the people who have this blood type and people who have this blood type. So I can only work with the number within a given category. I can also say the percentage. 50% of the class had type whatever. So, but again, I'm working with numbers. I cannot add blood types and multiply and divide. Blood types are blood types, and I need to count them. I can count them. I can get the percentage, but I am limited to that. I cannot do more than that in the data that has the blood type. Same thing for men and women. I can say how many men and how many women in your class, and so on. So I'm dealing with the number within a given category. I can compare it to other categories, but I cannot do much more than that. Ordinal scale, on the other hand, ordinal from order, and it is a rank order on the basis of a discrete characteristic without known equal distance. I'll tell you what this means in just a second. For example, if I am testing sensation on a person with diabetic neuropathy, for example, and I'm testing sensation of the foot and leg, I can have normal sensation, or I can have so and so sensation, so that would be impaired. So the patient will tell you that I feel something but not as good as I'm feeling it on my arm, for example. Or I can have totally absent sensation. No matter what I do, the patient is not feeling anything. So I have 3 levels of sensation. 1 is better than 2. 2 is better than 3. So I have an order. So ordinal scale, I have an order of in this scale. Manual muscle test is another scale that has an order. A person with quadriceps strength of 5 is stronger than a person with quadriceps strength of 4, and that 4 is more than 3, 3 is more than 2, 2 is more than 1, and 0 would be the quadriceps is totally paralyzed. So this is another scale that has 5 points, and again it is rank ordered, and it is going down to 0. In many surveys, and I don't know how much you study surveys or do surveys, but in many questions on a survey, it will give you a statement. For example, I like this course, and then you will have strongly agree, or just agree, or disagree, which means I don't like this course, or strongly disagree, which means I hate this course. And this is a Likert scale. It's called, this is just the name, a Likert scale. Obviously, strongly agree is higher than agree, higher than disagree, and disagree higher than strongly disagree. If I'm looking at a sprained ligament or strained muscle, I can grade the sprain or the strain or the ligament tear to grade 1, grade 2, or grade 3. Obviously, grade 3 is the worst case scenario in here. So this statement, again, now I hope it's clear that we have rank ordered on the basis of a discrete characteristic without known equal distance. We'll get to the part of equal distance. Is the distance between 5 and 4 the same as between 4 and 3, the same as between 3 and 2? In other words, is 4 double the 2? So I can say that the person with quadriceps strength 2 has half of the strength of the person who has a quadriceps strength of 4. The answer is no. There is no known distance between these intervals. Same thing with normal, impaired, and absent sensation. I cannot say that impaired sensation is 50% of sensation, or 40% of sensation. The distance between normal and impaired is not the same as the distance between impaired and absent. This is not the midway between this and this. But this is saying that some sensation is absent. How much? We don't know. Same thing here. So it is a rank ordered on the basis of the characteristic, but without known equal distance. And this is important to remember. So the difference between one score and another is not known. In manual muscle test, 4 is not twice as strong as 2. Functional and disability questionnaires usually have these types of questions. For example, the FIM, which is the Functional Independent Measure, the Ashwestray Disability Index is another index. Let me show you an example. For example, this is the modified Ashwestray Disability Questionnaire, and it has many sections, several sections. This section happens to be on lifting. This is going to ask the question about lifting. 0, obviously, that the person can lift heavy weights without increase in pain. So that would be, remember, it's a disability scale. So the higher the number, the higher the disability. So 0 is no problem. 5 is I cannot lift or carry anything at all. So if you have 2, it means that pain prevents me from lifting heavy weights off the floor, but I can manage if the weights are conveniently positioned. Okay? So again, from 0 to 5, 2 is not necessarily half of 4, and so on. Section 4 about walking. So 0 would be pain does not prevent me from walking any distance. 5, I am in bed most of the time and have to crawl to the toilet. So if I have 3, then pain prevents me from walking more than a quarter mile or a quarter kilometer. So these scales are very common in the practice of physical therapy. keep in mind that they are ordered, they are rank ordered. Keep in mind that they don't carry or they don't have an equal distance between the scores. Interval scale, on the other hand, is an interesting scale. It is rank ordered again. It has known intervals between units. The interesting thing about the interval scale that it lacks absolute magnitude because is not related to a true zero. So a true zero, we all know what is a true zero. A true zero means nothing, means absence of the criteria. So if I have zero memory on my computer, means I don't have any memory on the computer. So zero, an absolute zero, we all know, and it means nothing. In the interval scale, zero does not mean nothing. It reflects a phenomenon, or it has a definition. It is not nothing. The best example to illustrate interval scale is temperature, whether it's Fahrenheit or Celsius. 0 degree in temperature it doesn't mean that there is no temperature. 0, we all know, is a freezing point in the Celsius scale. So in here, the 0 means something. It is not the absence of the phenomenon or the criteria. In the interval scale, you have positive values and negative values. So -5 in the Celsius scale, for example, because I know you're more familiar with Celsius scale than Fahrenheit scale. So -5 means something, and it means that it is a temperature below the freezing point of 0. +5 means it is 5 points above 0. So the quantities identified with an interval scale may have positive or negative value, and these values may be added and subtracted. So I can add temperatures, I can subtract temperature, but I cannot multiply or divide temperature. So interval scales, remember, in the nominal scales I can add and I can get a percentage of numbers. In here I can add and subtract, but I cannot multiply or divide the temperature. Also in here there is a rank order. In here there is no true 0. It is not an absolute 0. 0 here is a phenomenon or a number that has a definition, and the scale can carry a negative number or a positive number. The ratio scale, which is the most precise of all scale, again it has a rank order, a known equal distance between the points, and a known empirical 0 point. So the 0 point is the end of the scale. We cannot have negative value in a ratio scale. Ratio scale is, we have many variables that fit under the ratio scales. For example, weight. We can have 0 weight, which means it weighs nothing. 0 height, it means the height is 0. It doesn't have a height. But we cannot have negative weight. We cannot have negative height. Blood pressure is never negative. If there is no blood pressure, if the person is dead, then blood pressure is 0. Range of motion can be 0. If the joint is very stiff, it doesn't move, but it cannot be negative. Actually, in range of motion, I have to take this back. Although it shouldn't be negative, but it could be, like in hyperextension, sometimes we refer to it as negative, but it's not really negative. It is extension beyond a midpoint. Muscle torque, again, if the muscle is paralyzed, then the muscle torque is 0. There is no minus muscle torque. So it has a rank order. It has an equal distance. For example, if somebody's weight is 70 kilograms and somebody else's weight is 140 kilograms, then this person is twice as heavy as this person. So there is known distance and between the numbers on the scale. It can be directly transformed from one scale to another. I can transform pounds to kilograms, miles to kilometers, centimeters to inches. I can transform any of the units to other units. All mathematical and statistical operations are permissible for ratio scales. So ratio scales are precise. They can carry any value that is 0 or above, and I can do all kinds of mathematical operations and statistical operations on the ratio scales. Again, all this information is very, very important when we come to discuss statistics, because some statistical operations would fit some variables and would not fit other variables. And when we read the evidence again, we should be able to evaluate the accuracy of statistical operations that were done on these variables. This is a table from the book that we are using for the class, and it has a summary of all the different scales in one nice table. So I thought this is useful for you to have a summary table at the end. It facilitates comparison between the different scales in one place. So I hope this is helpful to you. All right, I think I'm going to stop here, and I hope this is helpful. Don't hesitate to contact me if you have any questions. Inshallah, next time I'll think of other questions that could be on the final, and we'll keep talking about the final until the time of final, so you will not have any anxiety about the questions. I wish you the best during this blessed month of Ramadan. Keep going, and good luck to you. Assalamu alaikum.